Hi, welcome to this video. If you are watching this video now, that means you have completed exercise 15B um, and you are ready to move on to exercise 15E. Okay, so let's look at the question that I have here. I got this question from example 7, and I'm going to solve this question a little bit differently from how the textbook does it. We will need our GDC, so make sure you have your GDC with you. So please pause the video and see, just understand what's the question here. All right, welcome back. So I hope you had the time to read through the question. And I'm not sure if you have noticed, this question is quite different from the ones we have been doing. So let's see what we know. So the question told us that the box contains a large number of carnations, and 1/4 are red. And that 1/4 would be my P. Oops, sorry, my bad. The 1/4 is my P. All right, so the rest are white. So the other 3/4, they're all white. And we're gonna pick flowers, carnations at random from the box. And they are asking us how many flowers we must pick so that the probability that there is at least one red is greater than 0.95. All right, so please pause and think about what the question is asking. Are they asking us to find P? Are they asking us to find N? Are they asking, what is the question asking? And I hope your answer is they're asking us to find the N. How many flowers we must pick so that the probability that there is at least one red is greater than 0.95. So this 0.95 here, that's already been given to us. They actually gave us the probability. Right? So, but before we jump in and do any math, I should always start with the right math notation, which is my random variable x is binomially distributed, and my n is, I don't know what's n, and that's what I need to find, and the p in this case is 1/4. And also this 0.95 part, the probability that there is at least one red, which means this is what I have. The probability that my random variable x, which is the number of flowers I'm going to pick, at least one red, so one is okay, but if we're more than one, that's fine, is more than 0.95. In the previous examples, in the previous exercises that we have done, that we did, they are always asking us to find this value. They will give us the n, give us the p, and we just have to find the probability. But in this example here, it is slightly different because they actually gave us the probability already, but they want us to find how many flowers we need to pick, or the n. They want us to find the n. So that's why in the textbook, they show you guys a different way, a more algebraic way. But I'm going to show you guys how to solve the question using your GDC. All right. So another way to say the probability of x greater than or equal to 1, I can say that as 1 minus the probability of x equals to 0. And I think you guys, if you had already done the previous exercises that I assigned, you should understand what I mean by here. Because the only scenario where I don't want would be when I get zero red. Right? So the probability where x is greater than or equal to 1, that would be everything, which is the 1 here, minus what I don't want. Okay? Now with that, I can replace what I have originally here with this. And I come up with this expression here. Please feel free to rewind this section of the video. If you have no problem with what's going on so far, let's proceed. So now I'm going to go straight to my GDC. This P of X equals to 0, that is my Bino PDF, right? So I'm going to get my TI-84 and I'm going to use the table function. So once you turn it on, let me quit this. Okay, so this is the screen. I'm going to go to my y equals 2. And on the y1, I will type this, where my p of x equals to 0, that would be Bino PDF. All right, so 1 minus second bars, that brings us to distribution. And I'm going to find my Bino PDF, my trials, and that's my n, which I don't know. So I'm going to use x to represent that. And my p in this case is 1/4. My x value here is 0, right? X equals to 0. And I'm done. So now my y1 has 1 minus Bino PDF, and my n is x, which is what we have to find, and the probability is 1/4, and my x, in this case, x equals to 0, so that's why the 0 is there. At this point, I'm just going to go to my table over here. So second graph brings us to table, and we have a list. The TI-84 gives us a list of values, right? Where my x column here represents my n, which is my answer, and my y1 gives me the probability. And the question that right now the question is interested in, what is the value of n so that the probability is greater than 0.95? Greater than 0.95. So all I have to do is to scroll down. So when my x is 1, I have 0.25. So that means if I only do it once, I will have a 0.25 chance. So you can see that the more flowers that I pick, the higher chance this becomes. And I'm just going to move down the table until I see a value that is greater than 0.95. So I'm getting close. When my x is 11, my probability is 0.95776, and that's my answer. This is my answer. All right, so on the textbook, you see that they approach this problem a more algebraic way, but in the end, they still ended up using a calculator. So it actually makes more sense. It actually makes more sense to use the table function of your GDC to solve this, and that way we can avoid the algebra stuff. Okay, so my final answer would be n equals to 11. All right, that's my final answer. So when you are showing workings, you should start with the right math notation in terms of binomial distribution. And then this is given to us by the question, the probability of x greater than or equal to 1, at least 1, right? It says at least 1, is greater than 0.95. And what I'm going to try to do is to try to change the way this looks. And I can represent p of x greater than or equal to 1. I can represent that using 1 minus p of x equal to 0. And this p of x equals 0 is my Bino PDF. So I go to my calculator and I just type that expression in. So what I have here for y1 is a GDC version of this expression here. All right. So and then after that, I go to my table. I just scroll up and down to find the probability that we're looking for. In this case, what's the x value or n value that will give us a probability more than 0.95, and we see that happens when my n is equal to 11. All right. Hope you guys find this video helpful. I will see you in the next one. Bye-bye.